All right, folks, this next lesson is going to be a bit of a detour. I originally wanted to teach you how to count and then move on with some other, medium kind of fun assignments, but I'm going to throw this in here. I can't teach you just counting in good conscience and call it an assignment. It's not fun enough. So I want to show you kind of what we're looking forward to, okay? To do this thing that we're going to do, you need to learn about two things. We're going to use the pen tool and draw lots of shapes later. But for now, I need you to know about stamp, and clear. Okay, clear gets rid of all the stamps. So there's still just one sprite. Stamp puts a temporary copy on the stage. Okay, the stage is still blank, but it basically draws a copy of the cat onto the stage. That cat can't move or rotate or anything. You kind of use this for drawing pictures, like you'd have a little bush and draw 10 bushes or something like that. You know what? And actually, I'm going to get rid of the cat because I think the cat's kind of annoying for this one. So I'm going to hit clear. There still is one cat. I'm going to see if I can delete the cat. Yeah. Another sprite. Let's go things. And I want to find something that's going to be fun to duplicate. Gosh, cakes, whatever. All those are interesting. Clouds. I'm thinking more environmental stuff. And you can't duplicate the world, folks. We only have one. Let's take care of it, please. Holly. Oh, snowflakes. Okay, let's do the snowflakes. You can do whatever you want. Choose something. I'm actually going to shrink-a-dink this bad boy because we are going to stamp several copies of it, okay? And if I do them too big, though, I'll only be able to stamp a few of them, okay? And the hard thing about snowflake is you got to stay in the middle. You can't click outside of it. Okay, so I want a bunch of stamped snowflakes, okay? Well, you're like, well, I know how to do that, Grammar. I just drag this out and stamp and stamp and stamp. Not quite what we're looking for, okay? Let me show you the one weird way to do it, okay? Green flag's clicked. Repeat. So let me describe quickly the task. The task, if you're an advanced student who just wants to know what the heck we're supposed to do, I want you to first stamp some sprite at a fixed repeating pattern. So like every 5 spaces have a snowflake, 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 snowflake. And also every 5 or so or 10, depends how big the sprite is, maybe 20 or so down. In a grid, okay? And I know what you're thinking. You're thinking grids are not fun. I'm an artist and I can't be bothered with math or learning how to do things at precise intervals. Well, that's fine. Be an artist and see where that gets you. The people who make the world move, the people who are scientists and engineers and computer scientists, are people who can work with fixed numbers, with given requirements that you must stamp. I must put the telephone poles every 20 feet, or even, well, not 20 feet, every 100 feet or whatever, or we can't have electricity, that's just an example. The bridge must have pillars every so often or it won't stand up, okay? So I'm going to start off artsy-fartsy, willy-nilly, and not just by stamping and moving wherever your heart feels like. And that's fine. I mean, there's a place for that. Even in computer science, there's a lot of times to be creative. And we're going to do that real quick. I'm going to clear this. I'm going to repeat 10 times. I'm going to use a block that's going to put the star in a certain spot, not glide. I'm not making a game or a movie where I want to see it fly around. I want to teleport it and make a copy. Teleport it, make a copy. Okay, that's the first assignment. This one's going to be artsy-fartsy, okay? So I'm going to repeat. I want 10 snowflakes. I'm going to go to X, Y. And if I go to there, I'm already there, right? Remember how this works. You drag it somewhere, these numbers update, or you can type numbers in, the most important being 0, 0, which is the center, right? And then I'm going to stamp. Make a copy there. Now my question for you is, how would I do this in an artsy-fartsy way? Just snowflake here, a snowflake there, a snowflake everywhere, a snowflake. Not falling snow yet. We'll get to that eventually. But how would I make snowflakes at random positions? Well, your first thought is going to be, well, I'm going to plug in random here, and that's going to make a random amount of snowflakes. Well, I'm going to plug it in somewhere, wherever it'll go, because I don't quite understand. No, you're going to plug it in for random X position, and let's just see what happens. I'm just going to click flag, and I'm actually just going to click this several times. Okay, boom, 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 boom. If you can watch the snowflake over there, it is jumping around. We're not going to stamp yet. We want to get our movement figured out first, because I hate clearing all the time. But I'm going to bring that out, too, because we're going to need it eventually. Go to here, go to there. Can you see that it's just going really small places? Let's see why. What is that X position? Well, it's 2, it's 5, it's 3. This random number, I don't know if we've used it before, but it just spits out random numbers 1 through 10. And you're like, well, I know how to change that. Well, do it. Now, when you start thinking in terms of ranges and domains, okay, and I don't even remember what those numbers mean in math class. I think is the range, the y value, and the domain's the x value. I can't remember. But you need to think, how big is my playing field? How big is the world? You know, if I'm an engineer making a bridge, how big's the river? What's the domain of my problem, or the range, the length? Okay. So rather than thinking in abstract math terms, let's put this in a real situation where we have this field that has certain sizes. Okay, how do I find? Let's go to the extremes. We should always kick the tires and see how far we can go. The furthest left I can go looks like negative 240. Can't go any further. Furthest right, positive 240. So my x positions, left and right, are negative 240 to positive 240. Now, just while we're here, how big a range of numbers is that? You're thinking, oh, it's 240. No, 0 to 240 is 240, and 0 to negative 240 is another 240. How do I figure out the total distance? Well, it's 240 two times, right? Two 240s. 240 dots here and 240 dots here. That's 480, right? Same thing in the y direction. It's not the same numbers. I go up here and I go up to positive 180. Down here is negative 180. Hey, that's half a circle. What's a full circle, or what's 2 times 180? It's 360. Okay, that's the domain and range. That's the size of my problem, or the possible values this snowflake should go. Okay, and I'm pretty sure the center of this costume is in its belly button. There's a center costume button right here. Yeah, and it is in the middle. Okay, so that's the middle of the snowflake at 240, 180 would put it up here, and it would just show part of it. Okay. So having said all that, let's go do this. Let's go draw some random snowflakes. And instead of 1 to 10. You know, that's dumb. Let's go the full size of the screen. What's my x values? If you forgot, let's go bring in the backdrop, other, and XY grid. Okay, this is a little bit better. I'm going to go back in just a second, but that shows me my possible values, okay? All right, let's go back to the blank. I want to draw snow on a white backdrop, okay? Back to scripts on the snowflake. Let's go. My x, I just said, was negative 240 to positive 240, and my y was somewhere between negative 180 and positive 180. Okay, now let's check this out. Boom, 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 and it's going too fast. I'm going to put a little bit of weight in there because I want to watch it, but I don't want to watch it for too long because I have a short attention span. I'm going to put 0.1 there. Boom, boom, boom. I don't know if that was too fast for the computer to keep track of, but it is jumping around. I'm just clicking it a few times, okay? And you're like, oh, this is good. This is a good beginning. But one snowflake is not enough, so let's just stamp that bad boy. And we don't have to wait anymore because the stamp will show us what happened. Boom, 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 boom. Go again, boom, boom, boom. Clicky, clicky. And this should just make you happy. You should feel godlike, maybe with a little g, as you watch the computer do what you tell it to do, and you start thinking of rules. Like, what are the rules? What's the parameters? What's the requirements? What do I want this thing to do? And if you give it the right commands, it obeys. That's the beauty of computers, unlike humans, right? If you give them the right commands, if you know how to talk to them, they do exactly what you tell them to. Okay? And you're like, oh, but maybe the computer should have feelings and decide if it wants to do what I tell it to. But that's when the robots rise up against us. So, what did I do here? Clear, go somewhere, stamp. Clear, go somewhere, stamp. That's not what I wanted. I wanted to clear before each time. And you're like, but Grammar, I liked it when it did a lot of snowflakes. I don't want to clear every time. Well, then make more snowflakes. And what the heck? Let's put a random number in there, too. Instead of 10, 50, 100, let's go between 50 and 100. And sometimes we'll have a lot of snow. 50 snow. Sometimes we'll have 70, 80, 85, whatever. And this is fun stuff, okay? Now, that's not all this assignment is. We talked about artsy-fartsy. This is all nice, but your random stuff's got to go away, okay? I'm going to leave the snowflake there because I liked it so much. I am going to clear real quick. And I'll just leave the snowflake. I'm not trying to clear the sprite. It can't clear. I'm going to leave this stuff alone, okay? I like it. I'm going to bring in I'm actually going to paint a new sprite, okay? Leave the snowflake alone. Your next task, the final task, is to, and check this out, to put a dot, a single pixel dot. So remember these numbers here. There are 480 by 360 possible dots. They're all empty or blank right now. You're going to paint a single dot as a sprite, and you're going to stamp that sprite every other space on every other line, okay? That's the last problem. Might sound difficult or scary. We're not using random. We're going to be scientists instead of artists now, okay? just because they make more money, and that's what this class is for. You don't get art credit, you get computer science or math credit, okay? All right, so we are, oh, why did I throw that away? That was there is an undelete for the last thing. I feel dumb now. I just ruined the snowflake. Don't do that. Don't ruin the snowflake. I'm not going back to snowflake, so I'm not going to do it. I am going to move on to the next thing. I'm going to paint a new sprite. You need to, I'm going to turn it red, okay? So choose a color that you can see, black, red. Don't choose white, light gray. Those are bad ideas. And I'm going to turn the line width that I draw to a single pixel, okay? If you draw this fat, your stamps will just overlap each other and you'll just see a solid red, okay? I'm going to undo. That's not enough. All the way down, the smallest line width. I'm going to tap once, click once. I'm going to go try to make sure my costume center is in the middle. It won't be exact. Oh gosh, I'm bad at this. Click once and then just assume, or click over to scripts. Okay, and it doesn't matter if it's exact, it'll still kind of work. And I don't know where this sprite is. Oh, there you are. One thing about Scratch is it's hard to drag and move small things, right? I finally got it, but here's what you want to do. You want to put this in the corner, not through your mouse, but through script, and stamp. Skip a space, stamp again, skip a space. So it's not going to be red, 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 red every pickle. It's going to be red, white, red, white, red, white, red, white, red, white. The next line, we can skip it. I mean, that's our goal, is to skip it. Let's just get going, okay? Let's first draw a line 1 pixel at a time and just start there, okay? So when I click the green flag for the, and it's going to draw snowflakes. No, it's moving the snowflake. Oh, that's okay. All right. So maybe I'll go detach the snowflake thing for now. I'll hook it back up, and I'm just actually going to hide the snowflake. Oh, I don't want you to ruin your. I want to see your snowflakes, so just leave it alone. It's okay if it stamps. We'll still be able to tell what's going on with our red dot. Okay, red dot, you're going to go somewhere. I'm going to put you just at the left side for now. Okay, so I'm going to actually not go all the way to the top corner. I can't drag anymore, and that's good. I shouldn't be able to drag it. I want to go put this in the middle. Remember, 0, 0, and all the way to the left. Okay, so here and then all the way to the left. If you can't remember where that is, you can go open that backdrop again, but that is an X value of, let's just move the mouse there. Can you see what's changing down there at these numbers? When I move this to 0, my X value goes to negative 240. So I'm going to go to negative 240 and still at 0. Okay, we're going to go to the top in a sec, which is 180, and work our way down, but let's start there. Okay, we're going to start there. And then I want to, so I'm going to click green flag, it's jumped over there. I want to stamp. And then move and stamp, move and stamp, move and stamp. Now, you might think I'm going to move one step and stamp. That's totally possible, but move and turn, again, are good. It's actually a polar coordinate system. If you've talked in math class about XY, Cartesian coordinates, versus polar, polar still has 0 in the middle, but you have a direction, an angle between 0 and 360, and a distance in, feet, inches, whatever your units are. But that's the polar coordinate system. That's good for race car games and stuff like that. It's actually easy to understand for most people. But our XY is going to be a lot better, okay? So we're going to stick with this go to XY. We're not going to move steps. We're just going to keep going to XY, okay? Now, I want to have exact control here. I want to say go to this exact number and then stamp. Go to this exact number and stamp, okay? So for now, I'm going to get a repeat block just to get started. And let's draw, I don't know, 200. Just let's do a ballpark. And what's going to happen here? I'm going to go to that exact position and stamp. This is a block that 200 times stamp, 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 stamp in the same place. What should happen before I stamp every time? I should move and stamp, move and stamp. And by that I mean not move steps. Oh, we could change the X and Y value. I'm not going to use those, okay? The problem with changing X and Y's is I feel like I have less control. I am going to make my own X and Y, okay? So do this. Make our own X to start off with. We'll make a Y in a second. And we're going to go to, not that negative 240 anymore. I'm going to go to my X, and I'm going to set my X to negative 240, okay? Before this runs. And you're like, what's going on here? Well, figure it out. I'm going over to the side. I'm going to repeat 200 times. I'm going to go to a new X position. The Y is still going to be 0. Again, I'm staying right in the middle for Y. And then I'm going to stamp. Okay? So what needs to change here? I'm going to not some solid value like 110 or 100. I'm going to a variable that starts at negative 240. And if the negative 240 is scaring you, start at 0 and work your way right from 0 to 2, 4, 6, 8. But what needs to happen to my x value every time? This is the important part. I don't need to set it every time. I need to change it. Let's try this. Change x by positive or negative 1. If I want to go right, that number needs to get bigger. I need to go more positive. Let's hit play and see if this works. Bop, 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 bop. It's going to repeat 200 times. That wasn't very scientific of me. I just gave it a ballpark, and it didn't even make it the middle, which would have taken 240 times, right? I am not going to repeat at all. Okay, that's all fine. Well, first off, let's start. If I want to do every other dot, let's clear and run it again. And I want to do every other dot, not connected, bop, bop, bop. I want to do this. What do I change? Got any ideas? We're still going to go to the x value. I just want to modify or control my x number. I'm going to change it by 2 every time. Heck, let's go change it by 3. And let's go 5. Notice it's going faster because it's not drawing as many dots. 5, 5. Every 10 now. Okay? And hopefully this gets your mind. And I'm going too far, right? It's still trying to draw. This jumped by 10 every time. 10 times 200 is 2,000. And there's not 2,000 dots to be had. There's not 2,000 width here. There's only like 480, right? So that was a, wrong number here. Maybe, let's do some math. If I want to go from exactly one side to the other, I start at negative 240. Why do I get to positive 240? Or sorry, 480. 48 times 10 is 480. Is that going to work? Let's try it. Boom. 1, 2, 3. Let's see if it stops right when, stopped right when I got there, okay? Remember, doing a thing repeatedly, moving 10 times, 48, repeating 48 times, moving 10, that's multiplication, right? That's 48 times of moving 10. That's what multiplication is a repeated thing, a repeated addition, right? Okay, so let's go look at this. Let's go do the whole thing. Okay, we're almost done with this. I want to start at the top left and do every other. I'm going to go every other just for mine. You can do whatever you want. And I'm not going to repeat. Okay, I want to have exact. The problem with repeat is I had to do some math, right? And, I know that whether you like math or not, it's easy to make mistakes when you try to do the math yourself. So let's be scientists and let the computer scientists and let the computer do the math for us, okay? Let's throw this away and let's use a repeat until block. I want you to pause here and see if you can figure out when you'd stop, okay? You're going to draw. You're starting at negative 240 again. You're going to go to negative 240, 0, and you're going to change by 2, 5, 10 every time, whatever. But when should you stop? When should you quit drawing? Repeat until my x value, okay, remember this diamond block, it's not sensing, it's not ands and ors, because we're not doing two-part comparisons. We've got a limited number of things. Pause the video, see if you can finish this off to draw, every other block using a repeat until. Well, I want to repeat until my x value is either greater than or less than some number. And because I started negative and I'm going this way, I want to go till it's greater than the max number, which was 240. Okay, check this out. Now I don't have to do any math. It's just going to draw it for me. And I can change this number without having to do more math. Let's try it. Boom, 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 boom. Okay, you're doing every second one. You can see red, white, space, 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 going behind the part of the snowflake. And it stopped right at the end. That's the beauty of this. I didn't have to do math, okay? Let's go by 5. Oh, that's right, and it's going to clear for me, so pop. 5. Is it going to stop at the right time? Yeah, because my x value got greater than 240. Let me show you what people frequently do. Sometimes they'll say equals 240, and if I do them by onesies or twosies, let's do twosies, we're going to be fine. 2, yeah, awesome. We're looking good, soldier. We're going to get to 240. The exact second it equals 240, stop. I go by 5s. I could run this and show you, but I want you to, and I should have asked you beforehand, can you think of a problem with using equals here? Okay, I'm going to hit play. And watch this x value. It should stop at 240. Repeat until x. Oh, I'm not very good at math. Anyway, check this out. You're kidding me. 3 times 8 is 24. Guys, will you please find me some prime number? 7 times 8. 7 times. Okay. Oh, goodness. There we go. Whew. Okay, can you see that number? It's getting to 1,200, 1,300. It's big. What happened was this condition never became true, right? Repeat untils are weird. They keep going while they're false, and they stop when they're true. So when x was negative 10 or negative 100, it was not equal to 240. But what did x get to? It got to, and if I did this, by odd number, yeah. Usually we just do it with even and odd numbers, and it makes more sense. But if I did this by every, okay, gosh. I don't know what the number it stops at is, but it's going to get to like 238, 237. No, it's not 230. I don't know what it's going to get to. 230 something. And it's going to skip 240, right? 7 times, there's no number that 7 times equals 240. It can't go evenly into that. If this is 280, it could, right? So the problem is that we're skipping. We go to like 235 and then 242 or whatever. So that's why equals are dangerous in programming, okay? It's only one exact number that works. What I want to do is a range of numbers, a whole bunch of numbers, anything greater than 240, and we're done. And now that the 7z's stops gracefully. And let's see, we got to 243, okay? And then it stopped because 243 was greater than 240. That was true, okay? That x is 243. That is greater than 240. That was true. All right, so yeah, we are close to being done. I want you to see if you can go to the top left and make a grid pattern, okay? You might not think grid patterns are neat, but when you start trying to make Minecraft or interesting engineering or science projects, you will want to be scientific and not always artsy, okay? All right, so pause the video here. I'm going to get you started. I'm going to make a y variable, and I'm going to use the y variable just kind of like I use my x variable, a little bit different, okay? And it actually is hard. It's harder than I'm letting on. You're going to start up here, it's going to draw, and then you're going to get stuck. What happens? How do I go to the next one? If you want to be a programmer for a living, if you can get this right now without any help, pause this video, man, I wish I would give you a piece of candy if you could do it without help, but I don't have any way of proving that because this is something I want to show everybody. So this is not a candy assignment, but if you show me you did it without help, I'll give you a high five. Without actually touching your skin. I don't know if I'm allowed to do that, but an error high five. Okay, so here we go, folks. I'm using the y, and let's get going. I'm going to set the y. It's not 240. It was positive 180 up in this corner. If you don't trust me, put your mouse there and read the numbers, okay? And it is 180 up there. We're going to repeat. We're still going to do the x here. The y is going to be 180. We're going to plug in y for the y value, and it's going to stay 1. If I did this right now, it would stay 180 the whole time, right? It goes up there. And I'm going to do let's do 5z's because that's going to go a little bit faster. Looking good. How do I get to the next line? What am I going to do here? Like, I got to repeat that did one line. Oh, gosh. This is so cool. This is one of the most powerful and confusing things in programming. Pause it if you haven't already. Try to do this. I'll give you a hint, and I'll give you another hint, comrade. Okay, we're gonna have Russian nesting dolls. I'm assuming if you paused it already, then you're doing it. But we're gonna do a nested repeat. Okay, this is gonna blow your mind maybe, but we're gonna repeat for the x, and then we're taking care of the x, same x, right? No, the x is changing. And then we're gonna change the y. So one question is, do I want to change, should the outer one be the one changing the y or the inner one? So you could draw this either way. You could draw it top to bottom, and then go 5, and then down. But since we're used to going left to right, that's how we read and stuff, that's what I'm going to do. And the outer thing is going to be controlling the y, okay? The inner one's going to happen a lot more. The inner one's going to happen, and then it's going to jump out to the outer one, and it's going to change the y, okay? I'm trying to think if there's an easier way to explain this. We're going to do this a few times later on in other units, but, let's do it. You'll see this again. I can't think of a simpler example, but let's go. Repeat until y is going to be like the x one, right? We're going to duplicate this. We're going to swap this out for a y. And y doesn't go to 240. It goes to, we started at positive 180, so it's going to go to negative 180 down at the bottom of the screen. And I'm going to draw xy. Does it work? Let's just hit play. freezes. Y is greater than negative 180. Well, that's true, 180. So this never happened. The 180 was greater than negative 180, and it never happened. So I need to right-click and flip that. I need to get down and less than 180. Okay, so I'm going to hit play. Okay, now it draws again. Again, run your programs frequently. Now what's going on here? It's still locked up. And you know what? This X isn't growing anymore. It's actually stuck in the outer Y loop because Y never changes. It never gets a chance to get smaller down to negative 180. So if I want to go from a high Y like 180 down to a lower Y, I need to change it, not by positive. What's going to happen if I change this? Let's run it again. Y just went to 700,000. It's going up too fast. Let's go down. Let's go from a positive high number to a small lower number. There we go. X is going across. And Y went to negative 181. Wait a minute. Did I do this right? Y is 180. Change Y by negative. Oh, it didn't draw. We did draw. If you try to change it in here, what's it going to do? It's going to go to diagonal. It's changing X and Y at the same time. Oh, we're not doing negative 5. Let's go negative 5. Okay, and we'll get more. You're like, hey, this looks like math class. I'm drawing lines. But we don't want to go diagonal. We want to do a full line of X's and then bump the Y down again and reset. We want to reset the X value back to the left side every time, right? So that's going to come at the end, set X to 0. And this could go at the top too. You could put it, it's going to, on this loop, it's going to be done and jump up here. So set X to 0. I'm just winging this. We need to plan this better. I'm going to hit play. And this is what's called evolutionary programming. If you don't know what the heck you're doing, you just keep plugging numbers in until it works. And that's actually a poor way of programming because you can make little changes forever and it might not be the right one. So you want to be an intelligent design programmer. So this X, we don't go to that. We go to negative 240 for the X, right? Let's try that. Boom. Done drawn, jump back. And we skip 5 in both X and the Y directions. You can change this to whatever you want. And I got my grid going, okay? I'm going to hit stop. I'm going to change these to 10 because I want it to go a little bit faster. We're going to go down 10 every time. And let's go see, could I put these up here? Oh, that's going to do this before the first time it draws. It would kind of work, but it would be a little bit off. It would go Y down 10 and X to the left. Let's try it. Yeah, notice it skipped the first line, but the rest of it's still working. I'll probably draw one line below. So I'm going to put this back after. It'll work better. And I'm going to do these by 40. 6 times 4 is 24. Does 40 go into 180? 4 doesn't go into 18. 6. Yeah, 60 is a work. So let's go 60 and negative 60. Okay, why am I doing it like this so big? Because I want it to go fast. Okay, and it looks... Yeah, I didn't do the bottom line. Let's go. Oh, that should have drawn the bottom line. Am I not? Why didn't I get to 180? Less than negative 180? No, that should have worked. I didn't get a bottom line. Can I not? Where did it stop at? Whoa. X, why did Y get to negative 240? I did something wrong. Oh, I did it. Oh. Anyway, that's not quite right, but okay, let's go smaller numbers. Let's go 10 and 10. Boom. I'm gonna let this finish off. We're pretty much done, okay? You could stamp at bigger intervals, a cooler thing. You could, and you're like, okay, now this is Minecraft. I could stamp a dirt block, everywhere, and then at bigger intervals or random intervals, I could go put some diamond or whatever. And hopefully this gets you thinking about grids and counting and performing operations, doing commands at fixed intervals, at certain spacings from each other. Okay? And all it is fancy counters. This is a X variable that started low and increased by 10 every time and stopped when it got to a certain number. The nesting is the hardest part here. The loop inside a loop. That part will drive you crazy. Maybe I should have done a repeat inside a repeat first. We'll do that later. When we go to Python, I'll go easier on you in Python. This is kind of advanced stuff, but if you understand this now, you'll be that much far ahead when we get there. So thanks for watching. See you next time.